Hello, grade 8 students. In this video, we're going to continue our second part of the lesson. In the first part, we talked about the parallelogram and its properties. And in the second part, we're going to talk about the special parallelograms. And as you know them, they are the rectangle, the rhombus, and the square. And we're going to identify their properties. So our objectives are to identify the special parallelograms, what are their conditions to prove them, and how to apply their properties of the median segment in a right triangle. So just a quick reminder, in the previous video, we've talked about the parallelogram, and we said that the parallelogram is a quadrilateral that have its opposite sides parallel and equal. It has the diagonals bisect each other, and it has the opposite sides parallel, the opposite sides equal, and the opposite angles are equal, and the adjacent angles are supplementary. The special parallelograms that we're going to talk about in this video are the rectangle, the rhombus, and the square. This is the rectangle, this is the rhombus, and this is the square. Now let us start with the first special parallelogram. Now you're going to know why do we call them special parallelograms. The first one is the rectangle. The rectangle, it's a quadrilateral that have its four angles are right. So actually, the rectangle, it has the same properties as the parallelogram plus four right angles. So you can say that, sorry, it's a straight parallelogram. So this is the rectangle. It has all the properties of the parallelogram. The opposite sides are equal. The opposite sides are parallel. Two pairs of opposite sides are equal and parallel. It has the opposite angles are equal. The sum of angles is 360 and the adjacent angles are supplementary. Now plus 4 right angles. So you should add one property on the properties of the parallelogram. So the conditions to say that the quadrilateral is a rectangle, if one of the following conditions is verified, if it has four right angles, then it's enough to say that this is a rectangle. It's a parallelogram with one right angle. So if you just prove it as a parallelogram and then you say, oh, it has one right angle, then definitely this is a rectangle. If it's a parallelogram having congruent diagonals, so the diagonals in the rectangle bisect each other and equal. So if you are proving a quadrilateral parallelogram when you say that the diagonals are bisecting each other plus the diagonals are equal, then definitely this is a rectangle. We can't just talk about the rectangle without talking about a special theorem in this rectangle. It's called, it's called the median segment theorem. I want you to look at the triangle ABC. You know that it's right at B, and you know that AC is the hypotenuse. M is the midpoint of AC because the diagonals are bisecting each other. Let me just show you. So, this is M, it's a midpoint, right? So, BM, we call BM, it's a median. You know that BM, it's a median in triangle ABC. So starting from now on, you can tell that BM is equal directly AC over 2. It's a median segment theorem in a right triangle. So suppose I'm not talking about a rectangle. I'm talking about any right triangle. This is a right triangle, and this is a midpoint. You know that this is a median. So starting from now on, the median equals hypotenuse over 2. Why? Because from the rectangle, you know that the diagonals bisect each other and equal. So all these parts are equal. So BM equals AC over 2. Now, the second one is the rhombus. The rhombus, it has 4 sides equal, or 4 equal sides. Look at this rhombus. The rhombus, it has the same properties as the parallelogram. The opposite sides are equal, the opposite sides are parallel. Two opposite sides are equal and parallel. The diagonals bisecting each other. The opposite angles also are equal, but you have to add plus for equal sides, or the diagonals, if you are proving the diagonals bisecting each other, oh, they are perpendicular, then this is a rhombus. So, conditions to say that this is a rhombus: if it has four equal sides, or if it's a parallelogram having equal sides, consecutive congruent sides, or if the diagonals bisecting each other and perpendicular at the same time. And here we go for the last one, which is the square. It's a quadrilateral having its four right angles and four equal sides. So the square, actually, it has all the properties. The opposite sides are equal, the opposite sides are parallel, four equal sides, four right angles, diagonals bisect each other, diagonals perpendicular, and diagonals equal. So it has all properties. Let us solve this exercise to check how do we prove a rectangle. ABC is a triangle. Let us draw any triangle. Pay attention when they tell you any triangle. Don't draw it special. Don't draw it isosceles or equilateral or right. Any triangle, scalene. AM is the altitude to BC. You know that altitude means height. So this is the height, AM. O is the midpoint of AC. So O is the midpoint of AC. So now I have AO equals OC. N is the symmetric of M with respect to O. So N is the symmetric of M with respect to O. That means O is the midpoint of MN. Now you need to prove AMCN a rectangle. So how we are going to prove that it's a rectangle? You know that in this quadrilateral, O is the midpoint of AC, then AO equals OC. N is the symmetric of M with respect to O, so MO equals ON. Then this quadrilateral is a parallelogram having diagonals bisect each other. We used to prove this before. But AMC equals 90. This is given, it's an altitude. So a parallelogram with one right angle, it's a rectangle. Then AMCN is a rectangle. Now let us solve an exercise about the median segment theorem. Triangle OIE is an isosceles triangle of vertex O. That means OI equals OE. And F is the symmetric of I with respect to O. So FO equals OI. Now we need to prove that FE is perpendicular to IE. Or in another word, we are going to try that this triangle is right. So you know that EO, it's a median because O is a midpoint. But EO is equal to OI, it's equal to OF. So EO is equal to the hypotenuse over 2. Then definitely this triangle is a right triangle because the median relative to IF is equal half the hypotenuse. So this triangle is right at E. Another question, we have two circles of centers O and O prime and of equal radii. So the radius, the radius of the first circle is equal to the radius of the second circle. What's the nature of quadrilateral OE, O prime, F? It's very easy. OE is equal to OF because they are radii in the same circle. O prime E is equal to O prime F. I'm going to show you just a second. So we just said that OE is equal to OF because they are radii in the same circle. And O prime E is equal to O prime F because also they are radii in the same circle. But you know that the two radii of the circles are equal. So now I have four equal sides. Four equal sides, then this is a rhombus. Okay? So now you are able to identify the special parallelograms from their properties, and you started to learn how do you prove that a quadrilateral is a rectangle or a rhombus or a square. And you know how to apply the property of the median segment in a right triangle.